Hello everyone, I hope you are doing well. In this video, we are going to solve the part 2 and 3 of this question. The part 1 has already been solved and I have uploaded its video. I'll pin its link in the comment section so you can check it out. So the part 2 says cobalt has a hexagonal structure. Okay, first of all, we'll read the statement, the first statement, which says that it has a hexagonal structure and its lattice parameters are given. In part 2 it says that consider a cobalt atom at origin. Okay, 0 0 0 0, this is a point at origin. Write down the positions of the nearest cobalt atoms on the same plane 0 0 0 1. Okay, we have to write down the positions of nearest cobalt atom on the plane 0001 and on the 0002 plane above the atom. Okay, so we have to write down the atoms that lie on the plane 0001 and 0002. Okay, and we have to write down their positions also. Okay, writing the position means we have to find out the direction Miller indices for those atoms. Okay, so it will be clear to you when we'll solve it. Okay, so the part 3 says draw the plane. We have to draw two of the planes which are given. Okay, their Miller-Brevis indices, or we can say that the 4-digit Miller indices are given, and we have to draw them on the hexagonal lattice, and we have to identify the direction 1 1 2 bar 0. Identifying the direction means we have to draw that direction on the hexagonal lattice. Okay, so these are the two parts that we are going to solve in this video. Let's start. So part 2 requires us to draw the stuff and also the part 3. So get ready with different colored markers or pencils or pointers, because they will help you to distinguish between atoms and planes. Okay, draw this diagonal line on 3 lines. Okay, and this horizontal line should not be very long. Okay, this is the centermost point, which we call as the center point. Okay, corresponding to the origin, so just above the origin. And I'm drawing these imaginary lines. Okay, these are the imaginary lines. They have nothing to do with the structure itself. We are just drawing them as two separate various sections of the lattice of the unit cell. There will be atom at the centermost point. Okay, this atom is at position O O O O. All right, and just keep that in mind, that if we are separating the digits by commas and enclosed in a round bracket, then it means that we are writing the coordinates of the point. This doesn't have anything to say about the planes. Okay, the Miller indices are represented by these continuous digits where commas are not there. All right, so this notation and this notation is different. This is Miller indices notation, Miller-Brevis indices, Miller indices notation for planes when they are enclosed by round brackets, and this is for coordinates. All right, so I am writing here the coordinates, and atoms are located at each of the corner of the unit cell. Okay, at each of the corner of the unit cell, and these are the atoms. These are the atoms on the basal plane or at the roof plane. Okay, and now these atoms corresponds to the plane 0001. Okay, as if we draw the plane 0001, then it will be this one plane. Okay, and we are writing the nearest most neighbors, which are these first neighbors in a unit cell. Okay, to this center atom, which is located at 000 position, because they are saying that cobalt at 0000 position is there, and we have to write the nearest cobalt atoms. Okay, that is why we are considering the first neighbors, not the next neighbors. Okay, these are the nearest neighbors to this centermost atom, and they are lying on 0001 plane. All right, now we have to draw the atoms which are lying on the 0002 plane. So you can see here that this first index is for A1, second is for A2, third is for A3, and fourth one is for Z. Okay, and to draw the plane from given Miller-Brevitz indices, we have to take the inverse of each of the index. Okay, taking the inverse of 0, 0, 0 gives you infinity, and taking the inverse of 2 gives you 1 over 2. This Z intercepts directs you to the given plane, because the other three indices are infinity. So the Z index will help us to determine the position of the 0002 plane, okay, which is half unit above this plane. Okay, it is 0001, okay, plane, and this one plane 0002 will be half unit above this plane. And in order to visualize, there will be some atoms, three atoms that will lie on this plane half unit above the basal plane, and these atoms will be lying, just for reference. Okay, I have drawn this base plane, you can see here. Okay, and these are the atoms on the basal plane, and okay, you can see here these are the atoms in the basal plane. This is the centermost atom, and these are the corner atoms, and they are the atoms that are lying half unit above this basal plane. And these are the three atoms, 1, 2, and 3. Okay, and their positions are mentioned here. Okay, I'll mention their position also right there, because their position needs to be determined in the question. So you can see here the structure, and these are half unit above this plane. All right, and these two planes are just similar planes. Oh, talking about this plane or this plane is equivalent. All right, so we'll draw these three atoms in this 2D diagram, because we don't need to draw it in 3D or 4D. Okay, so there will be an atom at this position. This position, you have to remember that position, you know, it is located right here. Okay, and this length is 1 by 3. Okay, and this whole length is 2 by 3. It will be clear to you after that. It will be needed, this data will be needed in determining the positions. One atom will lie in this triangle, the other one in this, and the other one in this. Okay, leaving one triangle empty. You have to draw the atom. One atom will reside close to this one atom, like that. The other one close to this one atom, like that, and this one atom. Okay, this atom will reside close to this one to this, and this one will reside close to this one atom. This hint will help you to draw them and find their positions. All right, let us name all of the atoms. Okay, this is the center atom, that its position doesn't need to be determined. Let this atom be A1, A2, A3. Let this atom be A4. Let this atom be A5, this A6, and let this atom be A7, this atom be A8, this atom be A9. Okay, these red atoms are on the plane 0001, while the other atoms are on, these blue atoms are on the plane 0002. Okay, and I have drawn them as a smaller atom, not because they are different from these atoms, just to differentiate the atoms. You can draw them of the same size as there, but the position will be confused in that way if you make bigger circles. Okay, you better make smaller circles to represent the atom, in order not to confuse their positions. So the next step is to determine the position of each of the atom that I have mentioned here. These are the nearest neighbor to the center atom. So for A1 atom, we need to determine the position in 3 coordinates. Okay, let us first mention the coordinate system. Let this be A1 axis. Okay, leaving this corner, the next corner will be A2 axis, and this one axis will be A3, but that axis is not needed here. Okay, Um, in determining the direction Miller indices, we only consider the 3D system in which we have A1, A2 and Z axis. It should be clear to you that these corner atoms are located at the basal region, so they are located at the position Z, that is equals to 0. Okay, for these basal plane atoms, okay, Z will be 0, their position with respect to Z will be 0, and for these 3 atoms they are located half unit above this basal plane, so their position will be half with respect to Z axis. Okay, as you can see here, these 3 atoms were located half unit above this basal plane. Okay, I have drawn the 2D equivalent diagram just like as we are seeing from above. I have not drawn the 3D diagram to avoid the confusion, but you have to remember that these 3 blue atoms are located half unit above the basal plane. So finding the directions or positions in HCP is a little different than the conventional ways. Okay, you just have to move along A1 or A2 axis. Okay, the Z coordinate is already known for all of the atoms. We just need to find out the A1 and A2 coordinates, and by coordinates we mean that we have to move only along A1 and A2 axis. We are not allowed to move along A3 axis. This is A3 axis, okay, and this is negative A3 axis. We are not allowed to move along A3 axis. We have to find out the positions just by moving along A1 direction and A2 direction, or this is negative A2 direction and negative A1 direction. We can only move along the A1 axis. Negative is also included. So let's find the position of A1 atom, okay, from origin. Starting from origin, finding the coordinates mean what we have to do, how much we have to move in order to reach the location of that atom. Okay, so from starting from origin, in order to get to A1, what we have to do is to move 1 unit along A2 axis. This is A2 axis. Okay, we just have to move 1 unit. 1 unit means from origin to the other corner of the unit cell. Okay, so we have to move 1 unit along A2 axis and we will reach A1 atom. So the coordinates will be, we are writing the coordinates. Okay, keep that in mind. So we do not need to move along A1 axis because we just need to move along A2 axis and we'll reach the A1 atom. So first digit will correspond to A1, second digit will correspond to A2, and third digit will correspond to Z. Okay? So for A1, we do not have to move along A1. It is not needed. We have to move only 1 unit along A2 axis. So it means 1. And we know the location of these atoms. They are at basal plane, so Z will be 0 here. Okay, this is the location of A1 in 3-digit coordinates, but we have to convert them into 4-digit coordinates. We'll convert them later. First, we'll find out the position of each of the atom in 3 coordinates. So for A2 now, for A2, here is A2 atom. Okay, and we can see here from origin, this line corresponds to the negative A1 axis, and just moving along the negative A1 axis by 1 unit means from this corner to this corner, which means 1. Okay, half of this length will correspond to 1/2. Okay, this is 1/3 and like that. Okay, the fractions could be considered, but we just have to move 1 unit along the negative A1 axis and we'll reach A2 atom. So it means, since it is negative A1 axis, so we'll have to move -1 along A1 axis, comma, we are writing the coordinates here. Just keep that in mind. We are not writing the Miller indices here. So -1 unit along A1 axis, first digit corresponds to A1. That is why I wrote -1 because we moved along A1 axis. So no movement along the A2 axis is needed, and we know that they are at basal plane, so Z will be 0 here too. Okay, coordinates for A2. These are the 3-digit coordinates. We have to find out the 4-digit coordinates. Just keep that in mind. We'll do the mathematics after we'll find the 3 coordinates, because to avoid the confusion, we'll do one thing at a time. So for A3, here is the A3, and you cannot simply move along this line to reach A3 because it is along A3 axis. Okay, this is along A3 axis and we are not allowed to move along A3 axis. So there is a way we can reach to this point by moving along the A1 and A2 axis lines, okay, or the lines parallel to them. What we have to do is to take this one path from origin to this point like that, and then from this point like that. Okay, this horizontal line is parallel to A2 axis, so we can move along this axis line, and this is parallel to A1 axis, so we can move along this. So from this point we'll first go there, we'll move -1 unit along A1 axis, and then after that we'll move in this direction, which is this direction, and this direction is negative A2 axis. So -1 unit, because we are moving to the other corner of the unit cell, -1 unit along the negative A2 axis, okay, and we'll reach the A3 atom. Okay, we can't move along this line because A3 axis is neglected here. Okay, in 3 coordinate system, A3 axis is not considered at all. We are not allowed to move along A3. We have to do it by using the A1 and A2 axis only. That is why we have to move negative unit along negative A1 axis, negative unit along negative A2 axis. Okay, both of them will be negative, and Z is 0 for the basal atoms. Now for A4, I hope this is clear to you. The similar thing is used in order to find out the Miller indices for directions in HCP. Okay, for HCP the situation becomes a little different because the position and the coordinate systems are different from that of a cube. Okay, so the A4 atom is here, and it's simple. We just have to move -1 unit along the negative A2 axis. Okay, from this point to this point, which is along A2 axis. So we do not have to move along A1, so it will be 0 here, and -1 along A2 axis, and we'll reach A4 atom here, and Z is 0, we all know. For A5 is here. You can see here from this to this is parallel to a positive A1 axis. So 1 unit along positive A1 axis, which is this, and do not need to move along A2, and Z is already 0. Now for A6, here is the last atom on the basal plane, which is A6, and we'll do the similar thing. We'll move like we can't move like that, okay, because this is parallel to negative A3 axis. This is positive A3 axis, this is negative A3 axis. We cannot simply move like that. What we have to do is we'll move right there, 1 unit along the positive axis, A2 axis, and after that we have to move parallel to this, which is parallel to positive A1 axis. So we'll move 1 unit along the A1 axis, and we'll reach A6. So 1 unit along A2, 1 unit along A1, and this movement is positive, so 1 1 and 0. These are the final coordinates for the atoms lying on the basal plane. Okay, now we need to find out the position of these atoms, okay, which are slightly different. Now for A7 is closer to this atom, A9 is closer to this atom, A8 is closer to this atom, okay, and they are close by 1/3 units. Okay, it's 1/3 here also, 1/3 here also, 1/3 here also, and 1/3 here also, 1/3 here, this, and 1/3 along this also. Okay, so that the other lengths are 2/3. You can confirm it. I'll show you. So for A7 atom, what we have to do, we'll move, since it is 1/3 unit here now, so we'll move 1/3 unit along this point. Okay, we'll reach this point, and then we'll move horizontally 1/3 unit along A2 axis to reach that point. Okay, so it's 1/3 here and 1/3 here. Now let's see what axes are these. So this direction is negative A1, so we are moving negative A3 here. Okay, and this direction is positive A2, so we'll moving positive 1/3 units along A2. Okay, the polarity needs to be determined, so -1/3 units along A1 we are moving in this direction. Okay, and 1 by positive 1 by 3 units along A2 axis, and it's not 0, keep that in mind. These are located 1 by 2 units above the basal plane, so it's 1 by 2 here. All right, so yeah, now for A8, A8 is located closer to this atom. Okay, but it is far, slightly far from this atom. This position, to reach this position, what we have to do is we'll move like that and then like that. Okay, we'll move first along A2 and then along this direction, which is negative A1. Okay, this is negative A2 and this is negative A1. You can see here this direction is moving along. This direction means we are moving along negative A1. Moving along this direction means we are moving along negative A2. We have to move these units. What these units are: this length is 1 by 3. Okay, this length is 1 by 3 and this total length is 1. Okay, if we subtract 1 by 3, we will get this one length. You can do it taking the LCM. It will give you 2 by 3. So this length is 2 by 3. Okay, and this length is 1 by 3, as we already know. So, and both of these movements are on the negative axis, so we'll take it as negative. We have to move negative 2 by 3 units along A2 axis and negative 1 by 3 units along the A1. So it's negative 1 by 3 along A1, negative 2 by 3 along A2, and 1 by 2 again for Z is similar. Okay, this thing is very tricky to make you understand. I'm just trying my level best in order to make that one thing clear to you people. Keep practicing. It is easy. You can do it. Now, in order now position of A9 is needed. The reason I'm uploading each of the parts separately is this. Now each of the part is very lengthy, you know, and the video length becomes very large, so I just prefer that if I'm shooting the next part, the previous part is already uploading. Just to save time, I'm doing it. So yeah, this is the A9 atom, the last atom. Its position in 3D coordinates we are finding out, and then we have to convert into we have to convert it into the 4-digit coordinates. Okay, because in HCP we usually use the 4D coordinates. So yeah, this is the origin and we have to reach there. So this length is 1 by 3 and this bigger length will be 2 by 3. Keep that in mind. We'll move 2 by 3 units like that along A1 axis, positive A1 axis, and then we'll move in this direction to reach A9, and this direction is positive A2. So 2 by 3 along A1, 1 by 3 along A2. 2 by 3 along A1 and 1 by 3 along A2, and 1 by 2 is the position of these atoms on the z-axis, as I told earlier. Okay, yeah, these are the final locations. Okay, keep that in mind. Okay, it is closer to this. Okay, it will help you a lot in determining their positions. Okay, 1 by 3 units and closer to these neighbor atoms, and in which triangles they are residing. This triangle, then this triangle will be left blank, then this triangle blank atom, blank atom. Okay, so yeah, now we need to convert these 3-digit coordinates into 4-digit coordinates, and the transformation equations that we are going to use are similar to what we have derived in the problem 1. Okay, these equations which we use to convert the 3-digit Miller indices into 4-digit Miller indices, they are similar. A small disclaimer here: I will solve these equations for 3 to 4 of the position of the atoms. For others I will write the result directly. It is because these are simply the equation where we have to put these values. Okay, and it's not tricky at all. It's very easy, you can do it. If the problem becomes lengthy, then I'll skip it and you'll find it yourself. It's easy now after that. So h prime, k prime and l prime. This is h prime, this is k prime, and this is l prime. So in place of h prime you will write the a1 coordinate, in place of k prime you will write the a2 coordinate, in place of l prime you will write the z coordinate. Okay, so let us do for now finding now for 4-digit coordinates, 4-digit positions of atoms. Okay, first हम करेंगे now for 4-digit positions of atom. We are doing now this one calculation and I'm doing it for a1 atom. First, it's up to you that if you do this conversion just next to writing the 3-digit coordinates. Okay, it's up to you what kind of pattern you want to follow. For a1 atom we are going to do this, and h equals 1 by 3 to h prime. H prime means 0 minus k prime, which means 1. Okay, as I told earlier, this corresponds to h prime, k prime, and this corresponds to l prime. So 2 into 0 is 0, 0 minus 1 gives minus 1, so it's minus 1 by 3. Okay, the first coordinate is minus 1 by 3. For k to k prime is 1 minus h prime is 0, so 2 by 3 is the result. Okay, and I equals minus 1 by 3 h prime plus k prime. H prime is 0, k prime is 1, so it's again minus 1 by 3. L equals l prime, so l was 0 here. Okay, this corresponds to l. This corresponds to h prime, k prime, and l prime. There is nothing like I prime here. Okay, it's not needed, and it will be 0 again. So its 4-digit coordinates will be minus 1 by 3, 2 by 3, minus 1 by 3, 0. Okay, these are its 4-digit coordinates. Now you will do the similar thing for a2. Okay, simply just putting the values and you will get the answer. And for a2 you will get minus 2 by 3, 1 by 3, 1 by 3, 0. Okay, I will do it for maybe for this atom again, for this atom. Okay, for 2 of the atom, and for this it will be minus 1 by 3, minus 1 by 3, positive 2 by 3, and 0. For a4 the 4D coordinates will be 1 by 3, minus 2 by 3, 1 by 3, and 0. And for a5 it will be 2 by 3, minus 1 by 3, minus 1 by 3, and 0. For a6 it will be 1 by 3, 1 by 3, minus 2 by 3, and 0. For a7 and a8 I'll do the calculation for you. And for a9 it will be 1 by 3, 0, minus 1 by 3, and 1 by 2. Okay, let me write the final result for these two also, and I will derive these results. It's minus 1 by 3, 1 by 3, 0, and 1 by 2. Okay, and it's 0, minus 1 by 3, 1 by 3, 1 by 2. Okay, let me derive it for these two atoms. Here is the position of a7 atom. This is h prime, k prime, l prime. Okay, do mention these things while doing the calculation so that you may not confuse with what kind of values you are going to put in which formula and which value corresponds to which of the value. So 1 over 3, 2 into h prime minus k prime. 2 into h prime is minus 1 by 3 minus k prime, which is 1 over 3. It's 2 into 1, which is minus 2 by 3, minus 1 by 3. Will take the LCM, which gives us 3, and minus 2 minus 1. Minus 2 minus 1 gives you minus 3 by 3 dot 3. 1 3 just gets cancelled out, and it's minus 1 over 3. Okay, you can see here the first one was minus 1 over 3, and this is the similar that we got for H. Now we need to calculate K, and these are not Miller indices, these are the coordinates. Okay, here I am just writing coordinates in place of H, K, I, and L, H, K, L. Okay, don't confuse it with them. So 2 into k prime is 1 over 3 minus h prime, which is minus 1 over 3. Here 1 over 3, 2 by 3, minus into minus gives plus 1 over 3, and 1 by 3, taking the LCM, 2 plus 1 above there, 2 plus 1 gives you 3, and 3 just cancels out with it, and it's 1 by 3 for k. You can see here. Now for I equals minus 1 over 3 h prime plus k prime. H prime is minus 1 over 3, k prime is plus 1 over 3. So it's minus 1 over 3 plus 1 over 3. These two gives are, they sum up to give 0. Minus 1 over 3 into 0 is 0. Okay, 0 multiplies with any value to give 0 result. So L is equals to L prime. Okay, and you can see here that L prime is 1 over 2. So L will be 1 over 2 also. This is H minus 1 by 3, K 1 by 3, I 0, and 1 by 2 is this. So we have coordinates minus 1 over 3, comma 1 over 3, 0, and 1 by 2 is the last one. And this is what I have wrote here. Okay, you will do the similar thing for A8. I can't do it right now because the length of the video becomes very large. I hope the method is clear to you people. It's very easy. You can do it now. Now let's do the part 3 of this question, which says to draw the certain planes. Let me see. These are the planes. Okay, 1 0, 1 bar, and 1. We have to draw this plane on HCP and also this one plane. Okay, and we have to draw a direction also, which is 1 1, 2 bar 0. All right, so let's draw the planes first. So let us start drawing these planes, and first we'll draw this one plane. Okay, here we have H, K, I, and L. Okay, the first one shows for A1, second A2, third is for A3, and fourth one is for Z. We have Miller indices are given as H, K, I, L. We'll make the table. Okay, and the general rule is that for drawing the planes, we take the inverse reciprocal of the indices first. That will give us the needed intercepts. So we'll take the inverse of each of the index here. So inverse of 1 is 1, inverse of 0 is infinity. Okay, 1 over 0 is infinity, that is why we wrote it like that. Inverse of minus 1 is minus 1 again, and inverse of 1 is 1 again. Okay, so these are the intercepts for A1 axis, for A2 axis, for A3 axis, and for Z axis. All right, this is the first thing that we do before drawing the planes. Now let me draw the lattice, the HCP lattice, and we have to draw the 3D lattice here, the 4D lattice here actually, because Z is 1 here, and yeah. Okay, I'm drawing this on 3 lines. This is the roof plane. Okay, and draw vertical lines of equal length. Okay, that spans the equal number of blocks. Let me draw it on 4 blocks. Okay, 1 2 3 and 4 blocks. Every vertical line will be comprising 4 blocks. Then 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 and 4. Okay, now we'll join these lines together, this by this. Okay, this one is the basal plane, the above line is the roof plane, and the other ones are the vertical lines. Let me draw it just to distinguish it. Okay, the centermost point is origin. Okay, and let this be A1, leaving one corner, the next corner will be A2, leaving this one corner, and the next corner will be A3, and just vertical above will be the Z axis. Okay, so this is the HCP lattice. Now we need to draw the plane, and these were the intercepts for the plane. Okay, intercepts, consider the non-infinity ones here. A1 intercept is 1, so from origin, okay, starting from origin, 1 unit along A1 is this point to the other corner of the unit cell along A1. This is the 1 point on the plane. Okay, you will draw it like that. Okay, and this is 1 point on the plane. Next is A2 is infinity, leave it. A3 is -1. Where is A3? This direction is A3, so this direction is negative A3, and since it is 1 unit, so it means to the other corner of the unit cell along negative A3 direction, which is this point. This is the second point on the plane. Okay, and third one is 1 unit along Z. So whenever you are drawing the planes, you have to move starting from origin every time for each of the point. Okay, so for first I did it starting from origin, this point. Okay, and from A3 -1, I am not moving onwards from this point, but again from origin. Okay, again from origin -1 unit along A3, which was this one point. Now again from origin 1 unit along Z, which is this center point, because Z is moving is vertically upwards from the origin point, not this point but this center point. Okay, this is at the center of the roof plane, so this is the another point on the plane. We'll join these three points together in order to get our plane, and yes, this is our plane. Okay, and this plane you can check it that it is parallel to A2 axis. Okay, so yeah, this is one of the plane which was 1 0 1 bar 1. Now we need to draw the another plane which is 0 1 1 bar 0. Okay, HKIL 0 1 -1 and 0 1 bar means -1. Taking reciprocals, inverse of 0 is infinity, inverse of 1 is 1, inverse of -1 is -1, inverse of 0 is again infinity. Now we have two infinities, so infinity will be taken into account. When there is one infinity, there is no problem, but if there is two infinities in 4D coordinates, then we have to consider it. And now let us start with the points which are not infinity, then we'll deal with the infinity points. So this is for A2, this is for A1, A3 and Z. So for A2 we have to move 1 unit starting from origin along positive A2 sorry axis. So starting from origin, this is the point 1. Okay, and for A3, negative units along A3 direction. So this is positive A3 and this is negative A3. So this is another point, this one on the plane. Now we have Z as infinity and A1 is infinity. So what we have to do is to draw parallel lines along these 2 points. We have to draw the parallel lines from these 2 points to Z axis. Okay, infinity means that the plane is parallel to that axis, so Z has infinity, so we have to draw parallel lines from this point, okay, above to the other corner of the unit cell, which is this. We are moving vertically upward because parallel is for Z axis. Okay, so we are drawing parallel lines to Z axis, means vertically upward, also from this point. Okay, and it is parallel to A1 axis also. So from these points we'll draw parallel lines to A1 axis, which is this line, which is this line too. So we'll join these points together. So this is the second plane, which is 0 1 1 bar 0. Whichever intercept is infinity, what you have to do, we draw parallel lines from these points. The similar thing has been done for this one also. You can see this, that this plane is just parallel to A2 axis, because so these are the two planes, and the point of intersection of these 2 points and the point of intersection of these 2 planes is this one point. This point is common to this plane and also this plane, and this point is actually the, if you join this point with this point, tail at there, in a vector with tail at origin and head at this point of intersection, this this corresponds to direction which was given to be identified 112 bar 0. It is that direction. Okay, so you can mention it here. The point of intersection of two planes corresponds to the direction 112 bar 0. Okay, and you can confirm it by drawing the direction when the Miller indices are given. Okay, and for that purpose we have given h, k, I and l, which is 1, 1, 2 bar and 0. What we have to do is to convert these Miller indices into 3D system, because when you convert it into 3D system, then you will be able to draw the direction. So we need to find out the h prime, which is h minus I, k prime, which is k minus I, and l equals l prime. Okay, so h prime is h, which is 1, and I, which is minus 2 here. Okay, so 1 minus 2, which is 1 plus 2, which is 3. Okay, k, which is 1 minus 2, which gives us again 3. L equals L prime, which is 0. So we have H prime, K prime and L prime to be equals for direction. So square brackets 3, 3, 0, and for directions we have this thing. Okay, that the integer multiples are also equivalent. It means that this direction is equals to this direction is equivalent to this direction, and so on. Okay, so we can simply divide all of the indices by 3, and what we get is 1, 1, 0. Okay, this is the final direction. So if you find out the coordinates corresponding to these Miller indices starting from origin, this one is for a1, this is for a2, and the last one is for z. Z is 0. We do not have to move along z axis, just need to move along a1 and a2 by 1 units. So in drawing the directions, we do not take any reciprocal type of thing. Okay, we just divide the LCM by each of the value, and we have LCM here as 1, and dividing by 1 doesn't bring any change, so it is not needed here. But in drawing the planes, we have to take the reciprocals. So now it's 1 unit along a1, 1 unit along a2. So starting from origin, 1 unit along a1, which is this direction to the other corner of unit cell, and 1 unit along a2, which is this direction along onwards. Okay, in drawing the direction, we moves onward from the point where we left before, but in planes we always have to start from origin for each of the point, but not for directions. For direction, we move onwards from the point we left. So starting from origin, 1 unit along a1, and then onwards 1 unit along a2, which is this point. Okay, and hence it is confirmed that this point corresponds to this direction. Okay, in this way we have drawn the direction, the planes. Okay, and you can draw it using a different pencil. Let's say this. Okay, this is the direction. Okay, in this way the question is done.